So let me give a couple of, at least introduce myself. I'm Rick Riss. I'm an analyst at ARC. I have a background in process control, so I worked for the Foxborough Company for 20 years. I worked for a chemical plant for a few years in Niagara Falls, chlor-alkali plant. Um, at at Foxborough Company, I got into a very interesting group that basically tried to tackle all the hard to control problems, right? And we would give the new engineers problems like just go control the pH of this process, right? In an unbuffered solution where the precision is really high. So, but we also worked on all forms of reactor controls. We especially did a lot of work with distillation columns and distillation control. Every kind of reactive distillation, crude distillation, et cetera, compressor surge control. So I had a lot of experience doing that. And of course, in the process of doing that, you sometimes needed to build your own simulation just to test your complicated control system. Right? And occasionally we would use those simulations to train the operator. In fact, sometimes we would put that in front of the operator so he could train us about all the things we missed when we designed that control system that suddenly he needed to take into consideration. We would show him the graphical user interface, for example, and oftentimes they would come up with some very useful suggestions. So it was kind of an iterative process. We also had a lot of familiarity with simulations when we built large complex control systems and staged them, all right, prior to shipping them. And we needed to check every I/O point. And so you would build a checkout simulator, or in some cases. And in some cases, if you had a complete dynamic simulator, you would connect that. So at ARC, I've been with ARC for about 6 years now. I cover the market studies for operator training simulator suppliers, right? And I also have also moved from process control into control of electric grids, right? So to be part of that energy transition, I was very interested and curious about how to do that. That also reflects some of my own personal experience. I did some work on wind turbines for a German company. I was their US rep, and realized that they were much smarter than I was about wind turbines, but still, they're kind of complicated machines. But then I became a commissioner in my small town of Princeton, Massachusetts, which has a small electric grid, Princeton Municipal Light Department. We have 4 linemen and one office manager. We have no substations. We're purely a distribution system. But nevertheless, we own and operate 2 1.5 megawatt wind turbines. We're also trying to put in solar panels, a Tesla battery by offshore wind. So we're doing all of those kind of things that represent the energy transition. Anyway, we have some very distinguished speakers. Can we start with first presentation? Right? So let me just give a very brief introduction. We do have this Slido poll. It's just a very simple ranking poll, and that number here is, you can get to that poll just going slido.com if you can't read it with your QR code from that distance, 9977694. And if you put that in, we'll be able to take a look at the results. All right, and so the poll results will be like this. I think that was just probably my own random entry. Rate the importance of these operator training activities. Just drag the most, so you just select them and drag the most important one up. All right, wait a minute. Now I should have another slide here. That's it, huh? Well, let me just paraphrase what I think I would have otherwise said. There you go. So, in our operator training simulation research work, we kind of broke the simulation types into the simulation of the process, with various levels of fidelity, all right? We also, anybody that has used, anyone that's ever built mathematical models of processes, we kind of have this rule of thumb: all models are wrong, some are useful, all right? So the precision, you can get to very, very high precision. In some cases, that's justified. And a lot of the oil refineries and especially brand new process units certainly like to have a high resolution process simulation. But then there's the simulation of the control system. You know, in some cases, you could actually connect the actual control system to a simulator. So that's a very precise simulator because it is the same one. Or it could actually be different hardware with exact software running. So it's a replica control system. And then there is also the simulation of the spatial geometry of the manufacturing plant. All right. And there's some very creative ways that that's done. And in fact, we have some very interesting possibilities of how that's going to work with our esteemed panelists today.